A 42 ohm resistor is made from a conducting wire. The diameter of the wire is 0.3 millimeter, and the wire has a resistivity of 1.7 times 10 with the power of -8 ohm meter. Calculate the length of the wire. So we know the resistance R is equal to 24 ohm. We know the diameter here is equal to 0.3 milliliter. So the radius will be equal to 0.15 milliliter. And we also know the resistivity of the resistor, right? So this all tell us the formula we need to use, which is this resistance is equal to resistivity multiplied by length of the wire, which is what the problem asks for, divided by area. And area is equal to pi multiplied by r squared, so r is a radius. And this tells us that length of the wire is equal to pi r squared divided by resistivity multiplied by what? Oh, sorry, by r, right? So this is the equation we have, and you can just plug in number into the equation. So length is gonna be equal to pi, a constant, multiplied by radius 0.15. Sorry, here should be r squared, 0.15. And then you need to convert this quantity to SI unit of meter. So you multiply by 10 with the power of -3, and then square the quantity divided by the resistivity 1.7 multiplied by 10 with the power of -8, and then multiply the resistance, which is equal to 24. And this will give us the answer of 99.7 meter. On the axis, draw the graph to show how the resistance of the wire in D1 varies with the diameter of the wire when the length is constant. The data point for the diameter of 0.3 milliliter has already been plotted for you. So it's asking about this resistor here. So again, we know that resistance is equal to resistivity multiplied by length divided by area, and this gives us this equation. So from this we can tell that resistance is directly proportional to 1 over r squared, or you can say is inversely proportional to r squared as well. So this tells us if the diameter increases, what happens is r squared increases, so resistance gonna decreases, right? And it does make sense. It's just basic mathematical skill. So here will be something look like this, since it's proportional to 1 over r squared, right? So this is the answer we have. The 24 ohm is covered in an insulating material. Explain the reason for the difference between electrical properties of the insulating material and the electrical property of the wires. So insulating material. So we know that current, so let me write current instead of I. Current is the flow of electric charge. And because insulating materials have fewer free electrons than conductor, the current is being conducted by insulating material will be therefore smaller than conductor, right? So because insulating material have fewer free electrons than conductors. They have a smaller current. Right. An electrical circuit consists of a supply connected to a 24-ohm resistor in parallel with a variable resistor of resistance R. The supply has an electromotive force of 12 volt and an internal resistance of 11 ohms. Power supplies deliver maximum power to an external circuit when the resistance of the external circuit equal to the internal resistance of the power supply. Determine the value R for the circuit which maximum power is delivered to the external circuit. So this might be a little bit off the topic, but the conclusion here is very useful if you are planning to learn some advanced topic. So when the load resistance is equal to internal resistance, the circuit will have a maximum power. So this problem here asks us to calculate the value of R. So we know because the sum of this resistor here plus this resistor here, so the sum of this circuit here is gonna be equal to 11. You can calculate the value of R. And because those two resistors, the 24-ohm resistor and the variable resistor, are connected in parallel, you can use the equation here. It is equal to 1 over 24 plus 1 over R. So when resistors are connected in parallel, we know that 1 over sum is equal to 1 over R1 plus 1 over R2 plus plus 1 over Rn, where n is the number of resistors you have in a circuit. And this will give us the answer of 20.3 ohm for R, for variable resistor. Right. Calculate the reading on the ohm meter for the value of R you obtained in the previous question. So this problem, think about this question in this way, so you don't have to do the calculation. So what I'm gonna do is I'm gonna simplify this circuit. So here is the power supply, and you have a internal resistor here, and then here I am gonna to treat the two resistors in parallel as a whole. So I'm gonna combine them to one resistor. And we know that the question tells us the resistance of the external circuit equal to the internal resistance of the power supply. So here is also going to have a resistance of 11 ohm, because the internal resistance has a resistance of 11 ohm, and power supply here is 12 ohm. So here I have a current I, which is going to go through the internal resistor and the resistor of the external circuit. And because they have the same current, and they also have the same resistance, they're gonna have same volt number here. So here is gonna be 6 volt, and here will also be 6 volt, right? So the voltmeter here basically will read, let me change the color, will read the voltage over here, right? So it's gonna give us the answer of 6 volt. So let me explain this a little bit. So because they have same current and same resistance, it tells us they have the same voltage. And the voltage of the internal resistance plus the voltage of the external circuit is equal to 12 volt. So the reading by the voltmeter here is gonna be equal to 6 volt. So this is the answer here. You can also do the calculation if you want. So current will be equal to 12 divided by 22. This is the electromotive force. This is the sum of resistance. And then to calculate the voltage, you multiply by the resistance, which is 11 here. And this will also give you an answer of 6 volt. Calculate the total power dissipated in the circuit when the maximum power is being delivered to the external circuit. So power is equal to voltage squared divided by the sum of resistance, which is equal to 12 squared divided by 22 ohm. Right? And this will give us an answer of 6.54 watt. So if you don't see why, so here is the electromotive force, which is 12 volt. And here, because the internal resistance and the external resistor are connected in series, we are just simply gonna add them up to get the sum of resistance. So when resistance are in series, our sum is equal to R1 plus R2 plus Rn. So this is the formula we use. So for this problem, it's simply 11 ohm plus 11 ohm is equal to 22 ohm.